live stream, what we're going to be doing is we're going to actually be taking something that's so simple and so common that's in front of all of us, and that is an egg, and we're going to be then seeing how it applies to the cosmos. And you can take this as far as you want to. So I'm speaking of the lunar phases of the moon, and when I want to draw something like, let's say like the moon, lunar phases of the moon, you can easily go online and you can pull up phenomenal images from the internet of like close-up details of the moon, and you can sit there and trace like, or I should say like copy like every single little like subtle value shift and things of that sort. But when I work on something like the phases of the moon, what I like to do is I like to observe nature right in front of me and to think through it. So all of us were familiar with the angle of the sun as the moon is, going around the earth, and various things with rotation. I don't need to get into all the scientific end of things as far as the positioning of things, but rather I'm going to go into the aesthetic end of things and how you can use your knowledge of lighting a sphere to actually think through, then observe the light flowing over the surface of the moon, but also the craters. So to give you an example of this, one of the things that I really love is Galileo. Galileo is just, to me, he's one of my favorite scientists for the simple reason that he had so little at his disposal. And Galileo just had some hand-ground lenses made of glass, and he set them up, and he was able to come up with this incredible drawing of the moon. So it looks to me to be a watercolor, and he looked up in the night sky, and what's so incredible about these images is that Galileo was able to actually calculate the depth of the craters on the moon in 1609 by measuring the length of the shadows cast by the walls of the crater. I mean, that's incredible. If you can do that as a scientist, that's amazing. But also, one of the things I have to say about Galileo's drawings is that his drawings are very beautiful. His drawings have an understanding of the aesthetic, I don't want to say laws, but the aesthetic principles that guide us as artists. So with that, let's jump in. So I have my station right here. Here's simply put where I have all of my drawing stuff. And I'm going to be using a little bit of this graphite powder. This is just simple sandpaper, and I'm going to be dipping my finger in it at a certain point. But I wanted to show you the egg that I have set up. So right here, as you can see, I'm blocking my egg, and you can see I could spin that. I have 25 chickens in my backyard. I just grabbed one egg, and I'm using it spun towards me as an example of the sphere. So I just went like that. I try to make, in all these lessons, I want everything to be accessible. I don't want you to feel like you have to go out and you have to like buy an egg or something like that in order to like do this lesson. I'm sorry, go out and buy a sphere or a model of the moon. But what's cool is as you look at this egg, you can actually see the little divots on the surface of the egg, and they have a little bit of a shadow. So as you're working, I want you to think about the principles that we're looking at with the egg itself and see how we can roll them over to our drawing. So the phases of the moon that we're looking at today it is waning gibbous. And so our egg, again, jumping back to that, waning gibbous. So we're just going to jump over here. And what I would encourage you to do is, as you're working on this, that you would use a broad, a broad full arm approach. Circles can really tie people up. I mean, circles can really get people bent out of shape because you can tell when a circle's not perfect so easily. So as I'm doing this shape right here, notice I'm moving my whole entire arm. I'm not going like this and hatching small lines. I'm using my whole arm. So again, this is our waning gibbous. And once I've kind of masked out the shape of the circle, then what I'm going to do is I'm going to use the natural arc of my hand to map out that circle. So the mapping out of that circle, I want to be sure that as I do that, I'm not getting too preoccupied, too obsessed with like the ultimate perfection. Okay, so now I have this right here. I'm going to spin this over. I pull my hand off so I can see the full picture. And again, I'm using the natural arc, and that's why I spin the paper, so that I don't have to fight going backwards like that. So there we have roughly speaking, the external contour of our waning gibbous moon. And so now what I'm going to do is I'm going to observe the shadow shape on here. So the shadow shape runs kind of like this, like so. There is the boundary between light and dark. If you want, flip back and forth. You can look at the amazing drawings by Galileo and just kind of like see how he massed things in. Then obviously this is the side that cannot receive any light because it is turning away from the sun. And so this is going to disappear into shadow over here. Okay, so I have this pretty much locked in right there. So if you remember back to our sphere lessons, then we can do these halftones and things of that sort. We can get to that, but what I would encourage you with is before you get like too preoccupied with like all the halftones, that you would strengthen the external contour, and then we're gonna strengthen the inside of this shadow shape right here. And then we're going to talk about how we're going to aesthetically override perhaps a little bit of what we're seeing on the moon here. So Leonardo da Vinci, it's very interesting. He was the first artist, first individual to say that when you look at the moon, let's say the moon is like, you know, you can see a lot of the moon is in shadow. And when you look at that, but yet you can see the shadow side of the moon, you can say, well, how could that be? How could I see something that's in shadow on the moon? Because the universe is so dark and there's no reflected light hitting that from like way out in the universe. Like, and yet I can see some light on the shadow side of the moon from my position. I'm not talking about the far side of the moon. I'm talking about our side of the moon, the shadow. What Leonardo da Vinci pointed out was when you're seeing light in that shadow, what you're actually seeing is the sun's light bouncing off of our ocean and then hitting the moon. And so the sun, again, bounces off our ocean, the reflective surface of the ocean, shooting out at the moon. And so when we look up at the moon, sometimes we can see the moon in shadow. We can see some light in there, and that is literally our light. And so I just find that so interesting that Leonardo da Vinci was able to think that one through. And again, I bring this up all the time, but I think it's really useful. We draw in order to understand. We don't draw because we understand, but we draw in order to understand. So if you go through your love for art with that mindset that you're drawing in order to understand, it takes the pressure off of it because you don't have to arrive, you know, at a place of like supreme knowledge and okay, I thoroughly understand how to draw the anatomy of the hand, and so I'm going to draw the anatomy of the hand. That's very intimidating for myself, Kevin. But if I go to the hand and I say, okay, I'm going to draw the anatomy of the hand, not because I understand it, but I want to figure out how this thing works. I want to see, you know, what this tendon is right here. Then when you go with an inquisitive mind, everything starts opening up because you take the pressure off of yourself. So as I do this right here, look at all that reflected light that I'm putting there. Now I am looking over at the egg, but I'm also, you know, bringing my own aesthetic knowledge. And I'm saying, I'm going to force my knowledge of what this thing is, the aesthetic properties on the moon, and it's just going to pop it a little bit. It's just going to heighten it. It's definitely artistic license. So if you don't want to take artistic license, then don't. But on my end, like, just because this isn't a scientific text, I'm going to put like a fair amount of reflected light right there. And it really gives you a heightened sense of what the moon is. So let's jump over to some of our graphite powder. So you can take that on your finger, kind of like blend it like that. And again, this is just the product of me going like this with a pencil. And then we go back to our drawing, and this can help kind of speed things along a little bit. So it's common sandpaper from a hardware store, and I just stapled it onto a piece of 2x4 that was left over in my garage. Okay, so now I have this all mapped out. What I might do at this point, it's not a good idea, in my opinion, to blast the dark of the universe around it jet black, because sometimes when you get like a really dark pencil out and you go like push really, really hard into it, the paper ends up like looking glossy. And the paper ends up looking like it's kind of like shiny and slick. But for our purposes, you can indicate that yes, indeed, it is dark over there. But then as we approach the dark side of the moon, you can go a little bit lighter. Again, we're taking artistic license. When you look up at the moon, on the far side of the moon, it is not light over here, but we're pushing things in a direction that we want to. And it's worth noting that many great artists, you could consider them to a certain extent, some of them as being storytellers. So I think of myself, I think of Michelangelo. So I myself admire Michelangelo's ability to push a story and to heighten certain elements of something and to diminish other elements. So with his statue, let's say, of the David, or with his statue of the Pietà, the Pietà is a statue that has Mary holding the body of Jesus on her lap, and yet Jesus is a full-grown man. Mary kind of has the face of like a 19-year-old, and yet she has this full-grown man, 200 pounds probably, sitting on her lap, and it doesn't even faze her. So people would say that, oh, that's not realistic. Like, a woman wouldn't be able to hold a 200-pound man on her lap. And Mary should have looked older, because at that point in her life, she would have been, you know, like 45, 50, 55. But Michelangelo strayed from the literal, and he gave us the timeless and the eternal. He gave us the pure truth beyond the actual event. And, you know, that was his prerogative in storytelling. And it's significant to me that to this day, that is held as being one of the most beautiful depictions of Mary holding, you know, the body of Jesus, not understanding the suffering that she was going through, but trusting that it was to a purpose. You can say, well, how does this all pertain to a drawing of the moon? I took a lot of license right here. And I look at the old masters and I study them because they teach me about what it is to be an artist, what it is to be a storyteller. So I like the way that this is looking right here. I think it kind of looks cool. And so what I'm going to do is now, if you want, you can then hop over and you can, let's say, go on Wikimedia, and you can pull up images of the moon, and you can think about like the craters that exist like on the boundaries of the shadow shapes. And it's, you know, you can kind of like render some things in here and there. You don't want to put too much information, but you just want to put, you know, just enough. Now, as you're doing this, remember, you are looking, if you're looking at a crater, this is my coffee cup, which I had to clean a lot before I went on this video, because otherwise it would have been all stained. So if you see the light coming in and hitting on the far side of the coffee cup here, and then if you look at the light landing right here, that's a lot like a crater. So that's light coming from this direction. So if the light is coming in my moon right here, if the light is coming from, let's say, like this angle over here, for the phase of the moon that I'm on right here, it's going to cast the shadows on this side of the crater. And so this is really important for you to just like grasp as a concept, where the light is coming from, where the shadows will fall. So look again at the beautiful drawing by Galileo, and look at his amazing observation of these craters on the moon. And another thing I like to do when I teach art is I love to talk about the amazing way in which mathematics and art meet. I used to, my whole entire life, think that I really was terrible at math. And, you know, to a certain degree, I did very well all the way up to a certain point, and I got into college, and then I really just had to tap out. I couldn't keep up with the rest of the class when it got very advanced. But then I learned about how Leonardo da Vinci himself, he wasn't necessarily good at the mathematical end of things, and he was always soliciting help from other tutors to like push himself to the point where he could understand it. So Leonardo da Vinci wasn't able in the back end of mathematics to always understand it, but he could visually understand principles of, like, let's say, geometry, leverage, torque. And so in almost a back garden gate kind of way, he like was drawing and painting mathematics, but he was understanding the physics of things as like forces, like let's say as light striking an object or as water hitting a dam or something of that sort. So it really was a cool moment for me when I realized that I may not be able to understand everything when it comes to math. Like let's say my wife comes from a family that's absolutely brilliant with mathematics. However, I can see the visual manifestation of it. So with the moon right here, one thing that might be neat for you to just think about is that there's this law of statistics that randomness happens in clusters. And you could say, well, what on earth does that mean? Randomness happens in clusters. What it means is that when something is truly random, there will be many, many instances of the randomness being located in certain patterns, in certain pockets, but then other areas are going to be relatively devoid of whatever's taking place at random. So what that means for us is, as these asteroids or whatever bits of space debris pummeled the surface of the moon, they pummeled certain parts of the moon, but then they left other parts of the moon relatively intact and smooth. So what I would always recommend to people is to, when you're drawing something like, let's say, the craters on the moon, pick up on the fact that sometimes there's entire areas where never a single bit of space debris struck the moon. And think of that as you draw anything. Think of that as you draw grass in a field. Think of that, patches of grass when there's like also dirt. It's never spaced all perfectly, but it goes in clusters. So that's a mathematical principle of statistics applied to the visual element of drawing the moon. Okay, so we kind of have this like well mapped out. So let's jump over and let's go to the full-on stage of the moon, the full moon. To get the full moon, I have moved my eggs, the light, which is lighting my egg. The light is coming from, basically from our direction as a viewer. So it would be, if we're standing on Earth, it's the sun behind our back. And as you'll see, there's only a gentle halftone on the outer part of the egg. So jumping back to our drawing, this drawing tends to go like a little bit quicker. We're going to do another moon right here. And this moon right here, for being a full moon, what you can do, take all the principles that we used before. So you kind of like ghost out the external contour with your full arm. And then you kind of like lock in some shadows. The external contour with a stronger line. And you just flip it over, use the natural arc of your hand. Again, don't go for the most perfect circle. It's just something that could drive you mad. So just try to keep it very simple. All right, so that's as circular as I can get quickly drawing. And looking again at our reference photo, I have the gentle halftone on the outside right here. So what I'm going to do with my moon is I'm going to get a lighter pencil and I'm going to get the outer, that gentle halftone on the outside of it. I won't have the harsh, well, I shouldn't say harsh, but the heavy, dark that, like, let's say I had right here. I'm gonna have a much lighter, more delicate dance on this moon. So, okay, here's our full moon. Now, you could say, well, I look up at the full moon and actually, when I look at the full moon, I don't see any halftone coming, at the corners of it. You are correct. I am having you take something from nature that we're looking at, the egg, and then I'm having you apply a aesthetic concept that is not entirely true. I will take as as someone who perhaps engaged in a little bit of this aesthetic heightening, Galileo. And if you look at Galileo's drawings, Galileo would actually, in his drawings, sometimes on one side of the moon go a little bit heavier, darker with watercolor, and sometimes lighter. And again, it's just a way for us to understand it. There is accurate scientific rendering, and then there is, incredibly, there's incredibly complex scientific rendering, and then there is aesthetic, kind of like summarization of something. And that's what we're doing with this right here. We're summarizing it in a way that we want it to have dimension and it pops off. So going back to that whole mathematical idea of statistics, that randomness happens in clusters, what we're going to do with this full moon is we are going to just hint at, but not be, slaves of the patterns that we might see on the moon itself. And we're going to then jump back. And for all these things, I really recommend Wikimedia. And Wikimedia just has an incredible body of photography that I reference really often, because there are creative minds all over the world. And these creative individuals, they're uploading really neat things. If you are younger, always, ask your parents for permission to do something like that. And then once you have their permission and they're by your side, go ahead and look up. So I'm using this one Wikimedia user. I'll attach his name here. And he just uploads some pretty great photos of the moon. And so look at that, the randomness in clusters. There's nothing down at the bottom of this moon. I'll go back again to my reference subject, and it's pretty flat right there. So here I am going to go back in with my finger and roughly mapping this out. Now, you can, as an artist, really spend a lot of time on this. If you want to, and it's your call, you could go to town on this and get a really detailed study of the moon. And it's not a bad idea. For the purpose of this live stream, what I'm doing is I am just summarizing it to get the concept across, and then you guys run with it as you see fit. So just kind of alluding to the general pattern. And with that, I pretty much have the map out for the moon. Maybe I'm going to grab my blending stump and kind of get some detail as to how the land masses of the moon, I shouldn't say land masses, it's all just one mass of land, but they look like seas on the moon. And I encourage you, if you are interested in this, go in detail and study, just what's going on the surface of the moon. That's not the purpose of this drawing lesson today, to go like crazy in depth with like the chemical structure or anything like that. We're trying to capture the glory of the moon and see if we can expand our understanding of it a little bit. And now it's starting to pop a little bit more, just like that. So I'll do one last thing. I'll put in that one really cool crater down at the bottom. And then maybe I'll do some specific craters all throughout over there. So with that, we have our full moon, as you can see right here. And right beside it, we have our waning gibbous. So waning gibbous. And I hope you enjoyed this lesson. We have many more coming where the worlds of science and art, I actually think they're the same world. So the worlds of science and art, they meet together like this, and we just get to explore. So thanks so much, guys. See you next week. Live streams Tuesday at 2:30. Thanks so much for tuning in. Bye.